Now that we saw what is the unstructured and structured data, now I want to make you familiar with some of the topics that we are going to encounter throughout this course. And the first topic is outliers. Now, outliers are those data that does not conform to the maximum distribution of a data. Let me give you an example. So here I'm collecting the person's age. So I'm collecting their age, and I have quite a long data, almost, let's say it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. So I have collected 13 people's age as an observation, and the first person age was 75, second person was 80, and third and 65, and so on. Now I use this data and I did some visualization onto my data, and I plot box plot. Now this is what box plot looks like. So I plot the box plot, and in this box plot you can see most of the people's age that I have collected has the median age of near to the 75. That means most of their age are near to 75. And you can also see the maximum, that is maximum value of age that we might encounter through the box plot is 90, and the minimum is quite here, that might be around 45 data. So this is the 45. Now along with this box plot, you can see right at the top you have this dot into our data. See here, this dot. Now this dot is your outlier, and in our case the outlier is 110, because we have collected the 13 people information and most of their age are near to 75, and now one people age is away from this distribution. Their age, the people that I have collected, the people's age, the one people age is quite high here. So that is different from these distributions, because can you see here, some of these age are quite near to 75, but this age is well beyond the age 75. So that means this is an outlier. Similarly, if I take example of another, let us say that I'm collecting the information about the salary of a person. Let's say I'm collecting a salary of a person, and let us say I'm collecting some salary, let's say 100K was some salary of a person, and 200K. There are some people who have 50K as a salary. Now I also collected the salary of Elon Musk. Let's say Elon Musk's salary was around 2 billion. It is his annual salary, maybe more than this. He has earned so many money recently, but let us take a simple example that his salary is 2 billion. Now can you see here, the average people income is this much. Now Elon Musk here is an outlier. Elon Musk's salary is an outlier considering our salary. Now if I plot the graph is the graph for this one, then what I can get is something like this. I will get positively skewed distribution. See here, most of the people salary will be from, let's say, 50K. This is the 50K, and this is, let's say, 200K. So this is the 50K to 200K. Within this, that is range of a salary, I have collected most of the people's data. Now Elon Musk's salary will be somewhere here, which is 2 billion. So the higher values are minority here. They are in a less number, and lower values we have higher number for them, and that is what outlier means here. So considering that we have a small values and eventually we have one large values, then that large value will be outlier. Now let us see another scenario. I'm collecting the salary of billionaire people. So all of them are billionaires and I'm collecting their salary. Let's say some of them had 20 billion, some of them has 15 billions, some of them had 10 billions, and so on. Now I also collected a person who has lower salary, let's say 20k. So his salary is 20k. Now you can clearly see the majority of people here has the higher value. Now this smaller value will be our outlier, because this is not confronted. This does not comes into the standard scale of the maximum type of values that we have inside our column. So in this way we can find which one is outlier. Now in this case, if you see, then most of the people has bigger salary. Like here, let's say this is the 0 salary, then this will be my 10 salary, 10k salary, 20k salary. Similarly, I have here the billionaire salary. Let's say this is 10 billion, 20 billion, 30 billion, 40 billion, and so on. So here in this data you can see only one person has 20k salary, and all the above, that is this person has the salary that is bigger than this. So people will have more salary here. If I even collected more billionaire salary, then more of this billionaire will have data somewhere here, somewhere here. If I only collected the billionaire salary, and only if I collected some of the average people salary, let's say I collected and some of them had 30k and this much. So I collected 3 people, let's say 3 people that has the lower salary, and all others will billionaire. Then you can see billionaire people will be clustered here because they will have higher salary, and low salaried people will be clustered here. Now if I plot this graph just by this way, then you will see I got graph something like this. If I plot here, then I will give graph something like this. Now this is what negatively skewed data means. So earlier we saw positively skewed, now we saw negatively skewed. So if you have graph something like this, where the small values are in the higher number and greater values are in lower number, then this is positively skewed. And if you have a graph something like this, where you have lower values in a lower number and higher values in the greater number, then this is negatively skewed. So this is all the concept that you need to know about outliers. And to determine outliers, we have different method, and one of the method is also a box plot. Using box plot, we can visualize if we have outlier onto our data sets or not. So in our example, the person's age having 110 is considered as outliers, because all the other data are quite, that is common, they are near to 75, they are near to our median's age, but this one is well above the other's age. So this will be our outliers.